Hey everyone, we're going to go ahead and start our lesson on area of quadrilaterals with perpendicular diagonals. Okay, there is a specific formula for area of quadrilaterals with perpendicular diagonals, and that formula goes right here in this box. It is area is equal to 1/2 of the first diagonal times the second diagonal. So 1/2 d1 times d2. Okay. So what type of quadrilaterals have perpendicular diagonals? So you can use this formula, 1/2 d1 times d2, with these following three figures. Perpendicular diagonals, squares. Squares have perpendicular diagonals. You also know to find area of a square, it's just side times side. But you can also use this formula as well. Rhombi have perpendicular diagonals, and so do kites. So whenever we're trying to find the area of, usually it'll just be the rhombi or the kites, then you would use area formula 1/2 d1 times d2. Okay, so let's go ahead and apply that formula. Example 1, find the area of a quadrilateral that has perpendicular diagonals. Okay, so we don't know what kind of shape it is, but we do know that it has perpendicular diagonals. All that means is that the diagonals cross at 90-degree angles. And the diagonals are 4.5 meters and 9.7 meters. Okay, so we know that D1 is 4.5. I'm sorry, not 4.5, 15.4. And D2 is 9.7. Okay, so then we just plug that into our formula. 1/2 times D1. Our formula is 1/2 D1 D2. So 1/2 times D1 is 15.4 and D2 is 9.7. You can put this whole thing into your calculator. So let's go to our calculator. 1/2 I'm just going to use as 0.5 times 15.4 times 9.7. And you have your area of your quadrilateral, 74.69. And because we're measuring in meters, that would be meters squared because it is area. Okay. Number 2, find the D2 of a kite. So remember, kite is one of the shapes that we can use 1/2 D1 times D2 on. So find D2. So this time we don't know one of our diagonals, but we know D1 is 14 inches, and we know our area is 238 inches. So remember, our formula is area is equal to 1/2 D1 times D2. So I know that the area, so I already know that our area is 238, so I'm going to plug that in. So the area is 238. That's equal to 1/2 times D1, which the problem told us was 14. But I don't know what D2 is. Okay, so really I'm just solving for this variable here, D2. That 2 does not have a value. It just means the second diagonal. So if that little 2 bothers you, you don't have to put it there. We just need the other D. So we're just solving for D here. So what I'm going to go ahead and do is simplify 1/2 14D. Well, half of 14 is just 7. So this is really 7D. 1/2 of 14D is 7D. And then just to get the D by itself, or D2, we would simply divide by 7. So our second diagonal, we can also call it D2, is 238 divided by 7. So let's calculate that. 238 divided by 7 is 34. And again, this is not the area, this is just the length of the diagonal, so we don't have to square it. It's just 34 inches is our second diagonal. Okay, example 3. This looks like a square to me. All 4 of the sides are the same and the diagonals are perpendicular. We know that because they are marked with a right angle sign. Okay, we also know that BE is 4 and EC is 3. In this case, we're having to find the area and the perimeter of this figure. Okay, so right now we're missing other parts of our diagonal, and we're also missing the side lengths because we need the perimeter of this square. So something easy to look at really fast is you have a right triangle from B to E to C. Okay, that makes a right triangle. You also notice that the side lengths are 3 and 4, which automatically makes the hypotenuse 5 because it's a 3, 4, 5 triangle. If you weren't sure of that, again, you could use Pythagorean theorem. 3 squared plus 4 squared equaled we're not sure squared. 3 plus 3 squared is 9, plus 4 squared is 16. 9 and 16 is 25. And then you square root the 25, so C is equal to 5. That is where that came from, a 3, 4, 5 triple. Okay, so since this is a square, and you have all the tick marks here labeled, that means all the sides are congruent, so each side is 5. Also, with squares, we know that our diagonals bisect each other. So if this is a 4, then our other side over here has to be a 4. And E to C is 3, then that means A to E also has to be 3. So now we have found everything that we need to know about this square. Let's go ahead and start with our perimeter because that's the easiest thing to find. It's just the distance around our square. It's 4 sides and they're all 5s, so 4 times 5 is 20. Or 5 plus 5 plus 5 plus 5 is 20, and we're measuring in meters. So that is our perimeter. We also need to find the area. We could do side squared, but I wanted to show you how the formula that we've learned today also works, which is 1/2 d1 times d2. Okay, so we're going to continue with our formula. So we need to know what our two diagonals are. D1, it doesn't matter which diagonal is your D1, from A to C or from D to B. I'm just going to pick A to C. A to C is the 3 and the 3 together, which is 6. And then diagonal 2 would have to be from D to B, which is the 4 and 4 together, which is 8. Now originally when we looked at this picture, we thought that this was a square because all 4 sides are the same and it had perpendicular diagonals. However, now that we look at the diagonals, we see that they are not equal. For a square, the two diagonals would have to be the same length. But since these two diagonals are not the same length, this shape is actually a rhombus. Notice that there are not 4 right angles that are marked. So we have to assume that this is a rhombus and not a square. So because it's a rhombus, we have to use area equals 1/2 d1 times d2. So 1/2, our first diagonal is 6, our second diagonal is 8. If you want to go ahead and do this in your head instead of putting in your calculator, you would only take 1/2 of the 6. You would not take 1/2 of the 6 and the 8. Or you would multiply the 6 and the 8 together, then take half of the product. So let's just do it the first way. 1/2 of 6 is just 3, and then times 8 would be 24. Again, it's meters squared. And if you weren't quite sure of how to do that, again, you could always use your calculator. 0.5 times 6 times 8, and it gives you 24. Okay, we're going to move on. Number 4, we're actually going to save for class, so let's move on to the back of our notes. Number 5, okay, notice here that we have a kite. This is a kite shape, and we know that in kites that the diagonals are perpendicular. So again, the formula area equals 1/2 d1 times d2 applies here. Okay, we're looking to find y and the area of the kite. So we have to find y, which is part of our diagonal, before we can actually find the area. So remember that your diagonals are all perpendicular. And so notice again, y is a part of a right triangle, just like our previous problem we worked on. Except for this isn't as easy of a triple as a 3, 4, 5. It's some side plus another 20 squared would equal your C, which is 29. So our 29 is our C value. Our 20 can be either our A or our B, and we're looking for, in this case, I'm marking it as our B. So we need to plug in to our Pythagorean theorem, A squared plus B squared equals C squared. A here I've labeled as 20, so 20 squared plus, we're not sure what our B is, in this case our Y, is equal to C squared, 29 squared. So 20 squared, 20 times 20 is 400, plus B squared equals 29 squared, which is 841. Okay, subtract 400 from both sides. So B squared is equal to 441. Okay, I need to find the square root of 441. Second, x squared gives my square root of 441. And we have a nice whole number of 21. So once you take the square root of 441 is 21 inches. So that would actually be our y. Our y is 21. Okay, the nice thing about that is in kites, this diagonal right here is cut in half by this diagonal. So that means if this side is 21, then this other diagonal over here also has to be 21. Okay, so now we have all of our pieces of our diagonals filled in. So we need to start filling in our formula. D1, it doesn't matter if you pick this long diagonal here or this shorter diagonal here for it to be your D1. Let's just start with a shorter diagonal. The whole thing would be 21 and 21 added together, which would be 42. The long diagonal we're going to mark as our D2, which would be 20 and 28 added together. The whole diagonal of the kite, that would be 48. Now we can plug these numbers into our formula. A equals 1/2 of our D1, which is 42, and our D2, which is 48. Let's go to our calculators. 0.5 times 42 times 48 gives us 1008. So the area of this kite is 1008 inches. I'm sorry, inches squared. Don't forget the squared. And we've answered all of our questions. We were looking for y. Y is 21, and we were looking for the area, which is 1008 inches squared. Okay, these last two questions, 6 and 7, we're actually going to wait on them until we get to class. And so I will see you guys tomorrow for this lesson.